So now we come back to the PNP bipolar junction transistor emitter follower. We got it set so it's 5 volts. Now the other side of the LED is coming from 5 volts. There's no voltage difference. As I lower the trim pot voltage, first I got to lower it about 0.6 volts, but after that point, then our emitter voltage of the PNP bipolar junction transistor will go down. And now we got enough voltage difference from the 5 volt supply going down to get the LED to light up a fair amount. And of course it's going to get brighter. Now, of course, since this is a PNP bipolar junction transistor emitter follower, we can only get the emitter down to about 0.6 volts. It won't go all the way down to 0 volts ground right there. But in any case, that's our emitter follower with the PNP bipolar junction transistor. So now, our PNP bipolar junction transistor emitter follower circuit with the LED load right here. So it's coming from the positive supply. Now, sometimes there's actually a negative voltage in relationship to ground. In those cases, ground would be up over on the emitter side, whereas the negative 5 volts would be on the collector side. Be aware of that. But the main thing is, we have a voltage we can set with the trim pot all the way down to the negative supply, all the way up to the positive supply, whichever way ground is, doesn't matter. And we set that voltage to the base. We got about 0.6 volts higher at the emitter because of the emitter base drop. The transistor conducts as needed to take this voltage and get about 0.6 volts higher with the resistor there. So I used 10K. I actually got 1K on the board, but it doesn't matter. We also got a current path through our load right there, depending on the voltage difference. The farther we get away from this positive voltage, so a lower voltage there, more current through the LED.